Well, welcome to our new type of delivery. Today we're going to talk about the shortest job first scheduling algorithm. So in the past we did the first come first serve, which you should be very familiar with. It's a fair algorithm in that people or jobs get taken in the order in which they arrive. But it doesn't necessarily optimize for any of our metrics. We talked about our metrics being average wait time, average turnaround time, throughput. Shortest job first, on the other hand, does optimize for one of our metrics. It optimizes for throughput, as you'll see. So here we have a set of processes, 4 processes, and we're going to build a Gantt chart just like we did for first come first serve. And you can see that at time 0, none of the processes except for process 1 have arrived. And so process 1 gets scheduled first. It has a burst time of 7. However, at time 7, all the rest of the processes have arrived. And so instead of choosing just the next one to execute, we're going to choose the one that has the shortest burst time over here. So that would be process 3. Process 3 gets put in at time 7. It has a burst of 1, and so it goes until time 8. At that point, we have 2 more that are tied for the shortest burst time, and so we're going to take them in order. We're always going to break a tie with the order. So process 2 gets to go next, and process 4 will go last. Calculating the average wait time and the average throughput turnaround time is exactly the same as the way we did it in first come first serve. So here you can see that I actually wrote these times down in the order that the process is executed. So this is the wait time for process 1, wait time for process 3, wait time for process 2, and wait time for process 4. I think that's right. Actually, no. They're in the order. Yeah, I think they are in the order in which they're processed. So process 3, no, they're in the order of the numbering in this case. They're in process order. Sorry about that. Okay, so process 2 actually had to wait 6. Process 3 had to wait 3. And process 4 then had to wait 7. So our average wait time is 4. The average response time, we don't care about that. It's going to be the same as the average wait time because this also is a non-preemptive algorithm, which means that once a process starts, it's not going to get stopped, and so its wait time is going to be exactly the same as its response time. When we start talking about when we start talking about preemptive algorithms, these two will be different. So the throughput in 10 time units, you should notice here that in 10 time units, our throughput then is 2 processes. All right, so go ahead and pause the video and see if you can calculate this particular set of processes using the shortest job first algorithm. I also want you to implement a Gantt chart for first come first serve so that you can compare the metrics. So you're going to determine the average turnaround time, the average waiting time, and the throughput in 9 time units for the algorithms. And then I want you to compare the metrics and think about the reasons for the differences. And then we'll talk about why you would choose one algorithm over the other. So go ahead and pause the video, build those Gantt charts, and do the calculations. All right, so hopefully you've had a moment to build those Gantt charts. I'm just going to show you the one for shortest job first. Again, at time 0, the only one that's there is P1, and so it gets put in first. Then at time 5, processes 2 and 3 are there, and the shortest one happens to be process 2, so it gets put in there. But at time 8, then process 4 has arrived as well, and process 4 happens to be shorter than process 3, so it gets to go in first. So here's the calculations. Here's the Gantt chart that I created, and here are the calculations down here. I'm just showing you the calculations for first come first serve. But if you look at them, you should notice that the throughput is better for the shortest job first, which makes sense. And so if you think about it, what would be the reason why a system designer would choose shortest job first over first come, first serve? You should realize that if a system designer was trying to build a system that optimized the number of processes that got through quickly so that they could report that this particular scheduling algorithm gets a lot of jobs done fast, then they would want to choose shortest job first. In practice, shortest job first can't really be done. It's just kind of an illustration of how you can change the metrics. And why is it the case that shortest job first really can't be done? Well, the reason why shortest job first really can't be finished is because we don't know when we're running a program how long the next burst is going to be. For example, if we have a program that has a loop and the loop is dependent on a number that the user input, we have no idea how many times that loop is going to execute. It's possible to kind of keep a history of the running of the program, and so you can figure out how long a particular piece of code in a particular process ran the last time it was run, but that's not guaranteed. But it's an interesting illustration anyway. Next, we're going to look at priority scheduling. That'll be on the next video.